Welcome to the Target Course Open Vehicle Sketchpad Introduction to how to create and export STL files for 3D printing. I'm Brandon Litherland, and we're going to walk through how to get these files to work and then how to get them out into your slicing software. So to begin, we've got the model that we finished with in the wing design video here that's already scaled for millimeters at a 6-inch span. That's 152.4 millimeters and an area in square millimeters. Now, you'll notice that the wing looks right. It's got a nice sweep, it's got a nice taper ratio, the aspect ratio looks pretty good, and you may think, okay, we're ready to go. To demonstrate why we need to make some of the changes that are about to happen, let's assume that we jumped the gun and decided to go ahead and export an STL file with the part just as it is. Let's choose this one that I've already made, Wing1 STL, click Accept. The red mesh indicates that the file wrote just fine, and so here it is. You can choose different views for these parts, so you can make hidden, you can shade it, and it will fill it all in, and great, we have a solid part that we can print. But let's go and take a closer look at what the edges of this model actually look like. If we get in really close, you'll notice that there is a wedge on the leading edge of this wing, and it's choppy, it's got a bunch of straight lines in it, it's not very smooth and continuous. Now the reason for that is because we didn't increase the resolution of our model before we wrote it out, and this resulted in a very rough STL. Now by all means you can print something like this, but why not make it better? So let's delete this, go back into our wing, we're going to show this, and now we're going to go into some of the parameters that make this a much higher quality STL for printing. So in your handout, we went over how to change the tessellation and the number of cross sections inside your section. These are going to control how fine the mesh on top happens to be, and therefore how fine the STL you write out is going to be. So the default number of 33 numbered W sections, which goes from trailing edge around back to trailing edge, is actually quite rough. So let's go in and just take a look. These blue lines are the actual surface. This black, red highlighted line is the one that you want. So if we just crank this up, you'll see that a lot more points are filling in. And if we drag it all to the right, it stops at 133. If you click, you'll notice that we actually have a maximum value of up to 1,000. You should not need that many points. But let's say 201. That looks like a nice smooth surface. It's getting all the details that we want up here at the leading edge. It's even catching this little bump that's in the airfoil file. It's nice and clean. So that actually looks pretty good. But if you want even more points up here, you can go back into the Plan tab and say, I want the leading edge to be very, very smooth. I'm going to set this to 0.1 instead of 0.25 in this leading edge clustering. Now it's crammed a bunch more points in there, and that leading edge is actually quite smooth and clean now. So we have that set up, and we have our spacing in a way that's nice and acceptable in the chord direction, but we still have these really long, really high aspect ratio, narrow cells. We need more points inside there. So again, looking at your handout, you change this by the number of viewpoints in the cross sections, and you increase this, just keep going up and up and up and up and up. This actually has a limit built into it of 100. I'd say setting it to 100 for a single section wing is more than acceptable. If, for whatever reason, you feel like you need more points than that, you may split. And it hasn't changed the shape of your wing, but it has put 100 sections here and 100 sections here. And you'll notice that these cells are nice and rectangular now. So that makes a nice refined surface mesh to where we can now write out an STL file. We're going to repeat the process just like we did before, and go to File and Export. You can choose the Shown or All if you like. Click on Stereolith or STL. OK. Let's try and write that to Wing 1 again. Click Accept, And it's going to take a minute because there are a lot more points, but you'll see our red mesh is back. It wrote all the points. It filled in all these little triangles. And if we shade that part, let's take a look all the way down here at the leading edge. Notice how clean and smooth that line is now. We go back to a hidden view. Those are all the triangles that are written, and it's a much better file for printing. So you'll notice that if we go underneath here, this little cusp is actually captured in the STL now. This means that you're going to get better information out of your airfoil data. So because we've written this as a half span model, we can choose to print it out just like this. If you didn't quite like the way that that came out, let's delete it, go back, show this, say I want my entire model. Turn your symmetry back on so that we have our full wing. Let's do this one more time. Again, it's writing out a lot of points here, but it wrote just fine. Okay, so now we have an STL file that's ready to go into our 3D printing software. For an example, I'm using the Ultimaker Cura slicing software. You can use MakerBot or any other software that you happen to have for your 3D printing resources. But for mine, I'm just going to open the file. I'm going to go right into my folder, click on Wing 1. It's loading it in. You can see down here at the bottom. Now it should already be in millimeters. We shouldn't have to scale anything. It should read it right in and drop it right here on the print plate. And there it is. So if we move around, take a look, we can move it, we can orbit around, zoom in a little bit, and by checking the surface, taking a look at the individual parts, we are now able to set up our 3D print in any way that makes sense for you. Say, for example, we need to click and rotate this part, and we want it trailing edge down. Rotate it 90 degrees, and just for fun, let's rotate it 90 degrees this way, and we need to position it in such a way that it's actually touching. It looks like it's already done that, and snap to the bottom. Alright, so let's zoom out, rotate a little bit, and instead of solid view, let's go into a layer view. Now, depending on your print settings, your layer height, etc., the resolution on the surface of this body is going to be just a little bit different. So let's zoom in and take a quick look at what each of these paths might be. And looking along the edge, you see that we have these little ridges that go along the leading edge. That's not necessarily what you want. That's not going to make for a very clean print. Now, the way that you can try and avoid this, if we zoom out, it's usually good practice to take a wing model and print it in such a way that the span is vertical. So now, let's go in and rotate around and take a quick look. Each of our slices, if I can get a good view on this, are now in the chord direction. The printer can make an outline of each airfoil section as it moves up, and that's going to make a much nicer print. So it's going to make a much nicer version of your wing to go into your wind tunnel. You've got a nice base to attach everything to, and as you go up, your print will complete when it gets out here to the tip. So that's basically all that you need to do for your entire project, getting it from initial concept generation, learning how to use VSP, designing your wing, and finally exporting it out to an STL and bringing it into your slicing software. I hope these have been very useful. If you have any additional questions on how to operate VSP, by all means, talk to your instructor. You can email me. My email address is on the handout. We can get it worked out. If you have more questions about how to use VSP or would like to do something new or different, you are welcome to try and contact me. We can talk about that more. But good luck with your projects. I hope everything comes out well. Everyone have a great week, and we'll see you next time.